I'm Ethan Kwan, and today I'm going to be showing you what orbitals are and electron configuration. Okay, so here is a model of a helium atom. So this model of a helium atom is kind of obvious because this is the first model of an atom that was this was the last model of an atom that people believe to be true. So I will explain what is wrong with this model in a second, but let's see why people thought this first. Okay, so we all know that so this is a helium atom, and we know that protons, let me just, so protons have a positive, that's too big, protons have a positive charge, and electrons, let's just zoom in on this electron right here. Okay, here's an electron. So these have a negative charge, correct? Okay, so let me just draw the negative for this one too. Okay, so now we have a model of an atom, right? And people thought that the best model of an atom is that negatives always attract positives, so opposite charges attract, correct? Okay, so they thought that it looked like the atoms were orbiting, or the electrons were orbiting the protons, because that's what happens with a planet, right? But they were wrong. So this is not the exact model of an atom. It's true that the model could be like this. So the model was wrong because electrons don't really orbit the nucleus. A electron could be there, but it also could be here, or let me just increase the width size, or here, or here. It could be anywhere around the nucleus. But so scientists had to come up with another model to explain where all the electrons were. So let's just start with a proton. And so we're just going to start with a hydrogen atom. So we're just going to draw a small hydrogen atom really quickly. So here's the proton, and here is the electron. Actually, we're not even going to draw the electron right now. Oh, no, that's not the electron. So we're just going to change the color first. So here's our proton, right? Now, the electron, like I said, could be anywhere around the nucleus. So it could be here, right? But it also could be over here. It could be over here. It could be off the screen, right? So it could be anywhere in here. But but if we watch it for a period of time, a pattern emerges. So the pattern would be, okay, so we don't know where the electron is, but 90% of the time, maybe, it's going to be in this, it's going to be in here. It's going to be in this shell, right? I'm being messy on purpose. Let me just change the size of this. Oh, no. 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 Nah. Eh. No. 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 Okay, there we go. Fine, 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 fine. Okay, so yes, it's messy. So it's gonna be in this sphere. Now we can't show a sphere here, so this is just the best. 90% of the time it could be there. So it's most likely to be in this region. We don't know where it is, but it's probably here. It could be out here. It could be over here. It doesn't matter where it is. It just depends on where it seems to be. Okay? So now that is the first shell. That's the easiest way of viewing it. That's the first shell. Now, what happens if we give this electron a little bit more energy? Now, here's the problem with giving it a little bit of energy. The electron can only be in certain energy levels. This will make sense later. Or like I'll explain this in another video. Okay? So it could be in certain energy levels. So we have to give it a certain energy boost. So if we give this electron the certain amount of energy that it needs to be a better electron. So that's not the okay. Excited electron, let's just say. Okay, so then the electron shell, electron probability density, or most likely to be area, is gonna be a higher energy, right? Let me just speed this up for you. Nah. No. Well, you get the general idea. Okay, so it will be in this higher energy level, or what is called the 2s or the 2s shell. Okay, that's a formal definition. Okay, so what we're gonna do is now we're gonna give it a little bit more energy. So what happens if we give it a little bit more energy? Well, now this will become kind of weird. So, no. Okay. This will become kind of weird. So, instead of being in these perfect circles, like you would expect for an electron with a higher energy level to be in a shell like this, right? You thought wrong. An actual electron that would be in a higher energy level than 2s orbital would be in something called a dumbbell shape. So, I have to do this. Okay, while I'm drawing this, I'll tell you why. So think about a wave. A wave, because an electron is basically a wave, right? It's a particle and a wave, which is really weird, but bear with me. So an electron is both a particle and a wave. So a wave can be a standing wave or a sitting wave or whatever that is. Okay, so. Okay. So, the third electron shell would look like this. And actually, that's not exactly what it looks like. It could be in any of the 3 dimensions. I'll just tell you what I mean by that in a second. So, the reason this is because let's just say I take a piece of string, and here are the 2 points that I'm holding. No. and let's just say I wave it, it'll look like this. Oh, no, that's a horrible wave. There we go. So it'll look like that, right? So, and it might go on to do something like this, right? Okay, there's our dumbbell shape, right? Now, in 3 dimensions, this is kind of hard to imagine, but let's just say I have like a circle here, and I push down on this part of the drum, I guess you can say. I push down on this part might go down, and this part might go up, right? And then this part will go down and up, and so on, right? So that's why this is in a dumbbell shape. Let me just get rid of all this because I need that space. Okay, so now I'm just going to copy this because I don't really want to draw the whole thing again. That, and that, and that, and that, and that. Copy, paste, okay. Put that right there. Okay, now turn it. Okay, so an electron can be in any of the 3 dimensions. Okay, so so it can be anywhere on the XY axis or X axis. That's not a good. One sec. Okay, I'm having a little bit of trouble with this. Oh, no. Let's just turn the color back. Okay. Oh, no, that's too big. Nope. That's just horrible. You know what? I'll just, oh, no. I'll just checking the color and stuff. Okay, so, come on. You know, I'll just do this with a pen. So it can be on this axis, the x-axis, correct? The y-axis, y, or there's one more dimension, the z-axis, right? Okay, it's coming out, so I made the z big. Okay, so it can be on any of those axes. So that's cool. So here's a better drawing of the first few electron levels. Okay, so as you can see here, here's the 1s, and the 1s is actually just is this first one right here. So the first one, the blue one, is the 1s. So the 1s is just this circle here. So this is the 1s energy level. Now, this here is the second energy level. So we would call this 2s, correct? And this is and then we need another shell, right? So we need this shell right here, this one. And remember, there are 3 versions. So here's one version, here's the other, and here's another one. So this would be the 2p energy level, and this would also be a 2p, and this would also be a 2p. Now, to specify what dimension you're in, you can call this the 2px, the 2py, and the 2pz, correct? Okay, right, because this is the x-axis, this is the y-axis, and this is the coming out z-axis, right? Okay, so those are the shells. Well, the first few shells. Now I'm just gonna go get I'm gonna get a picture of more shells. Okay. Okay, this is like messed up. Okay, let me just shrink this. Okay. So here are a few of the I guess I can move this up here. Wait a second. Okay, I don't know where I put it. Okay, there it is. Okay, so I'll just keep this down here. Okay, so So here are the first few energy levels. So, for example, here, I'll just do this, yeah. So here is the 1s, right? And this is the 2p, and these are the D ones, 2D, and these will be the Fs. Okay. Okay, so now we have all the orbitals here, or the first few orbitals. Okay, so this is what atoms look like. Now, there is going to be a better version of this. Like, this is not exactly correct, but we don't know what is more correct than this. So, keep a lookout, folks. Okay, so each of these shells are, well, different, right? So each one will have different shell inside them, but that's kind of confusing, so I'll leave that out for now. Okay, so to understand this a little bit better and how electron configurations work, we're going to have to go over to a periodic table. Periodic table, where are you? Okay, here you are. Okay, so here's a periodic table, correct? Okay, so here's a periodic table. Now, let's look at hydrogen. So I'm just going to change the color back to white. Okay, so let's look at hydrogen. Let's look at hydrogen. So hydrogen is going to be in the first shell. So hydrogen is going to be equal to, or not equal to, is in the first shell. So I'll say 1s for the first shell, and each shell can hold up to 2 electrons. So the 1s shell can hold up to 2 electrons. So because there's only one shell, right? So the 1s, and there's 1 electron in hydrogen, so we would just put a superscript 1 up there. Now, helium, the next one, helium is, let's see, so hydrogen was 1s1, so helium is still going to be in the 1s orbital, but helium has 2 electrons, so 1s2. 152. 1s2, okay? Sorry about my s. Okay. Lithium, on the other hand, now we need another shell, right? So this is going to be 1s2 to hold the 2 electrons, right? And then we need another one. So 2, and then we're going to go to the 2s orbital. So they're 2s1. So you can't cram another electron into the 1s2 orbital. So 2s1, 251 again. That's 2s1. Okay. And then let's do beryllium. Okay. Be. Beryllium is going to be 1s2, 2s1. No, actually it's going to be 2 because there are 2 electrons in that shell. Okay, now we're going to do boron. Boron is another shell. So let's see, 1s. You know, I'll just actually use a text box. Here. 1s. Oh. Come on. 1s. Oh, wait, what? 1. Oh, got it. Okay. And we're going to just shrink that. 1s. Oh, wait, no, it's black. 1s. 2. 2s2. And then there's another shell, of course. So it's going to be 2, what was it? 2p, and then let's see, 2p, and then 1, right? Okay, now that's kind of weird, so I'm just gonna stretch this out. Okay, and shrink that. Okay, there we go. So that's boron. And now let's do something big, like, I don't know, let's see, rubidium. Now, rubidium is a really high atom. So actually, yeah, so I will write out the electron configuration for rubidium, and, let's see. So, actually, let's just do, chlorine. So chlorine, because rubidium is too big, oh wait, no. So Cl is equal to, and instead of writing the whole electron configuration, we're gonna find out a new way to do this, because this is gonna take a long time. So what we do is we go back to the last noble gas, right? So the last noble gas is neon. So we just write neon in these square brackets, Ne, neon, right? So that specifies for all of that. So, for example, if we wrote He, He, helium, then we would get this configuration out of it. But since neon is the higher element, we would use that. And then we would just continue on. So this is going to be the 3s, sorry, because that specifies the line at which you're at. So 3s 2, and then 3p5, right? Because there are 5 elements here, right? So you have to count up to 5. Okay, now here's a little bit of a confusing part. So you have to go in order, right? So for example, if you're doing zirconium, for example, you would go for 3p5, and then, wait a second, and then 4s2, and then, wait one second, yeah, so, and then interestingly, we would go into the 4d orbital. So this is going to be the D. So this is the D section here. This is the D section. So this is going to be the D, and this is going to be the S. These sections is going to be the S, and this is also in the S. And so this is in the S, and this is in the S. This is the P section. And yeah, so in the D section, interestingly, since there are 10 elements here, we would do 2, so it's 1 less than the row it is in. No, that would be 3, sorry, we're in the 4th row. 3D10. Cool, right? Okay, that's where I'm going to have to leave off for today. You can look up all the electron configurations of all the other atoms if you want. And I hope you liked this video. If you did, please press that thumbs up button, and please subscribe and share my channel with others. Thank you for watching, and I'll see you next time. Also, see how to do stuff with Ethan.com. See you next time. Bye.